Welcome to the Batteries of the Future report. There are some real downsides to today's lithium-ion batteries, stumbling blocks that are the focus of international discussion. The batteries can overheat through thermal runaway, which can result in devastating fires and explosions. They operate best in a fairly narrow temperature range, between 15 and 35 degrees Celsius. And the lifespan of lithium-ion batteries is limited to between 7 and 10 years, depending on their application. On top of that, lithium-ion battery manufacturers are at the mercy of both supply and pricing of a range of critical metals. Take lithium, for example. It's the most critical component of a lithium-ion battery, and the price has jumped sixfold since the start of this year, 2022, adding upwards pressure to production costs. Add to that, cobalt is considered the greatest material supply chain risk for the industry in the short to medium term. And whilst the Democratic Republic of Congo produces about 70% of the world's supply, human rights abuses continue to raise ethical concerns. There are also supply chain concerns around graphite and copper, which make up the anode part of the battery. The industry is heavily reliant on China because it produces 90% of all graphite anode material. Therein lies geopolitical risk. A standard electric vehicle requires 2.5 times more copper than a standard internal combustion vehicle. A recent report suggests there aren't enough copper mines being built or expanded to provide all the copper needed to produce electric vehicles into the future. But an alternative does exist. The solution is Altech Chemical's Serenity battery, which uses sodium alumina solid-state technology.
So you probably spend a lot of nights wondering this question. What is the future of grid storage batteries? But before I talk about that, I want to talk to you about solid-state technology. Who understands solid-state technology? The industry, the lithium industry, has been trying to move to solid-state technology. And in a lithium battery, there is a positive terminal and a negative terminal, the anode and the cathode. And in between that, there is a liquid electrolyte, which is flammable. There is also a plastic separator, which is also flammable. And that is causing the problems with battery fires, and that's why the industry is trying to remove that flammable material and replace it with solid-state technology. So solid-state technology is essentially a ceramic piece that allows the lithium ions to transfer back and forth. As in the video, you can see the problems with battery fires and explosions. That is essentially thermal runaway, and it may be caused by overheating, physical damage, or overcharging. But when it takes off, it's nearly impossible to put out a lithium-ion battery fire. Why is that the case? Because it generates oxygen at the cathode end of the battery. So in a normal fire, you douse the fire, take the oxygen away, and you put the fire out. In a lithium-ion battery, it generates oxygen. So that's one of the major problems with that. The other thing is that a lot of people don't realize lithium-ion batteries only operate in a narrow temperature range. So down to about 15 degrees to 35 degrees. When you get down to 0 degrees, actually your battery operates at 70% capacity. So that's a problem. The other issue is that lithium degrades every time you charge and discharge a battery. There are side reactions, and so generally a battery lasts for 8 to 10 years in the EV sector or the grid storage sector. Now, I know there's lithium companies in here, and they love the price of lithium shooting up fivefold in the last couple of years. But this has put a lot of pressure on the lithium-ion battery industry. The other main concern is the ethical concerns of cobalt supply. So 70% of cobalt comes from the Republic of Congo, and there are child labor issues, and the industry is concerned about those. Finally, 90% of graphite is actually supplied by one country around the world. So 90% of graphite comes from China, and it represents a geopolitical risk for the industry. Copper is the final puzzle. 2.5 times copper is used in an electric vehicle compared to an ICE vehicle. And there's a recent report that said there's not enough copper mines being developed to even meet the electric vehicle demand going forward. So is there a battery that actually is totally fireproof, has a life of beyond 15 years, operates in a large temperature range, has no lithium, no cobalt, no graphite, no copper, and no manganese? Ladies and gentlemen, this is the Serenity battery. A sodium chloride salt battery was developed by the Fraunhofer Battery Institute out of Germany. They've spent nearly 35 million euros in research and development, another 25 million euros in pilot plant work, and they were looking for a partner to commercialize it. And we are that partner. So number one, remember I said the flammable liquid? Our batteries are solid-state technology, so we don't have a flammable liquid. We use a ceramic tube as the solid electrolyte. So there's no thermal runaway. It is totally safe. It doesn't generate oxygen at the cathode end, so totally fireproof. Number two, it operates at a wide temperature range. It can operate down to minus 40 degrees. Why? It's because we don't have that liquid electrolyte, and it also has its internal temperature. So it operates at 270 degrees on the inside of the battery. It's fully insulated, you can touch it, but that's like a mammal. It regulates its own temperature. So you can operate this battery in really cold climates. Because we don't have the liquid electrolyte, it's solid-state technology, the sodium ions don't break down. So we have more than 15 years life of this battery. So we use sodium ions, which is in salt, and if you know your periodic table, sodium is just under lithium, and it's actually a very reactive material. And common salt is already available, it's cheap, and that's one of the big advantages. We also don't have cobalt. Our chemistry doesn't require cobalt to have the power of the battery. It's very similar to the lithium iron phosphate battery. So we're really not exposed to the cobalt supply chain. And finally, it hasn't got an anode. It's a self-forming anode. So we don't have graphite and we don't have copper. So that's a real big advantage. So let me talk about the chemistry. It's really neat technology. So essentially, we have a ceramic tube. That's the solid-state electrolyte. We add salt to it and nickel metal powder. And that essentially is the cathode end of the battery. It then sits in a metal cylinder. And that cylinder acts as the negative part of the battery. Now, the batteries are 250 watts. And essentially, that's what it looks like. The ceramic bit sits into the metal canister. Now, this is what happens when you charge the battery. The sodium ions migrate through the ceramic piece. It leaves the chloride behind, and the nickel grabs the chloride and becomes nickel chloride. The sodium forms on the other side of the battery as molten sodium, and when you discharge the battery, it dissolves away. So it's a self-forming anode. And this is what it looks like. When you charge, it forms an anode. When you discharge, it dissolves the anode. So that's why we don't have to have graphite or copper on the anode part of the battery. And this is when it's discharging. The sodium ions go back, grabs the chloride ions, and becomes salt again. Well, how does this battery stack up with other batteries? If you look at lithium iron phosphate battery or the sodium or the redox flow battery, It's very similar energy density to lithium iron phosphate batteries. Very similar energy conversion, but no maintenance costs, much safer and lower capital costs. If you look at the curve of where these batteries sit, you can see the lithium-ion battery on the left-hand side are cobalt nickel batteries, lots of power, and the bottom part of that is more energy, so not necessarily a lot of power. Our batteries sit in the middle of that. All right, the batteries that we're going to produce are only destined for the grid storage market. We're not interested in the EV market. It's overcrowded. The grid storage is the market you want to look for. It's a very early stage market, but as my friend Joe Lowry said in his presentation, the grid storage market is going to grow 20 times in this decade. So we're ready to commercialize this. This is some of the vision of the pilot plant that was built by the Fraunhofer Institute out of Germany, and they have produced these batteries and they're operating. So it's not an R&D program, it's actually been produced and performing. Our job is to commercialize it and build the first 100 megawatt battery plant in Germany. Okay, so part of the technology is mixing the alumina powder to make that ceramic tube. The key technology is to making that ceramic tube that allows the sodium to go through. It's like creating channels within that. So this is the 100 megawatt project in Saxony, Germany. Saxony is actually the east part of Germany on the border of Poland. And you can see there's a lot of development there with automakers and so on. And this is actually what our 100 megawatt plant would look like. And you can notice on the roof of that are all solar panels. So essentially we are generating our own power and it'll be a totally green project. So what's the cost of the batteries? The Fraunhofer Institute have estimated it should be 40% cheaper to make these batteries. Well, it sort of makes sense, right? We don't have lithium, we don't have copper, we don't have cobalt, we don't have manganese, we don't have graphite. So it sort of makes sense. Our first product is actually a 60 kilowatt battery. It contains about 240 of these cells, about 600 volts, and this is our initial product. What's unique about this is there are 5 shelves and there are no moving parts. Now, what's the problems of the grid storage market today is there is an extensive time to install these batteries. It's complex to put 20 of these batteries on site, to configure it up. The noise on the cooling fans of these batteries is a problem. It takes a lot of valuable space, and it requires a lot of regular maintenance. So at Altech, we've solved this problem, and last week we launched this.
In a breakthrough for battery technology, Australian company Altech Batteries has launched a design for a 1 megawatt hour sodium chloride Serenity battery pack destined for the renewable energy storage market. The product, called Grid Pack, uses an innovative new sodium chloride battery technology. One of the unique features of these batteries is that there are no moving parts, such as cooling fans, like in lithium-ion battery packs. They're totally silent and can be installed close to residential neighbourhoods. These innovative batteries can even function in extreme temperatures, from frigid cold to scorching desert heat. They also have a lifespan of over 15 years. That's nearly double a lithium-ion battery. The plug-and-play feature of the site installation for the grid packs ensures that they can be easily installed in remote locations. Additionally, the containers have been designed to be stackable, which minimises the battery footprint.
So, ladies and gentlemen, within 5 minutes of arriving at your site, we can have 1 megawatt of battery connected to your grid in 5 minutes. Thank you very much. Thanks, Smith.